All right, so in this lesson, we're going to be looking at some tables of values and trying to decide if they are either arithmetic or geometric patterns or neither one. Now, I want to make sure you understand before you go home to finish that there are only two on the entire set of worksheets that are neither arithmetic nor geometric. So make sure you don't try to get away with using that for 5 out of the 8 or something. Okay. So, number one, to decide what type of pattern, if you don't know right away at a first glance, start at the back, try subtracting. So 40 minus 20 is 20, 20 minus 10 is 10, therefore it cannot be arithmetic because I got two different answers. I tried dividing. 40 divided by 20 is 2, 20 divided by 10 is 2, 10 divided by 5 is 2. Since I got the same answer every time, when I divided, that means this is a geometric sequence. To get the next term, I multiply by 2. So that makes the recursive rule, well, we'll write down f of 1 equals 5. And also we will need f of x equals f of x minus 1 times 2. To find the nth term, so that's asking us really, what do we have to do to get any value? So if we look back at their example, what they mean is in words, we want to say where we start and how many times we do the adding or the multiplying. So to get the nth term, we will start with, now we don't start with 5 because that's not the 0th term. We would need to go backwards into this pattern one place. So if x were 0, going backwards, 5 divided by 2 is 2.5. So start with 2.5, then multiply by 2 n times. So if we were trying to get to the second term, we would start with 2.5 and multiply by 2 twice. Trying to get to the 5th term, start with 2.5, multiply by 2 5 times. That's really explaining the explicit rule in words. Our explicit rule here is f of x equals 0th term times the multiplier to the x power. Okay. Number 2, if we start from the back, 65, 61 divided by 81. 65, 61 divided by 81 is 81. 81 divided by 9 is 9. So it's not geometric because I did not get the same value when I divided. I can tell, obviously, that it is not arithmetic either because 65, 61 minus 81 and 81 minus 9 and 9 minus 3 are definitely going to give me very different answers. So this is one of our two that are neither of our identified sequences, which means we do not need to do the other 4 parts of the question. Number 3, I can see 33 minus 17 is 16. 17 minus 9 is 8, so it can't be arithmetic. To try for geometric, 33 divided by 17 is a long decimal, 1.94, so on. And 17 divided by 9 is a different decimal, 1.88, and so on. So this one is the last one on the worksheets that is neither arithmetic or geometric. So numbers 2 and number 3, you've already used up both of your neithers. Everything else you will need to identify as either arithmetic or geometric. So number 4 here, negative 53 minus negative 44. Now that's a lot of negative signs, but that answer is negative 9. Negative 44 minus negative 35 is negative 9. Negative 9, negative 9. So this one, if we are subtracting 9 each time, that is an arithmetic sequence. To get the next term, you subtract 9 or add negative 9 if you prefer. The recursive rule, we would say start with negative 8, and then to get each new term, take the last term and subtract 9. To find the nth term, well, to do that, I need the 0th. So if I go back one step in the pattern, instead of subtracting 9, I would add 9. That puts me at positive 1. So start with 1, then add negative 9 or subtract 9 n times. And the explicit rule, since this was an arithmetic sequence, it's going to be y equals mx plus b. It's f of x equals negative 9x plus the 0th term, 1. Number 5. Starting from the back, negative 486 minus 162 is negative 648, and 162 minus negative 54 is 216. So those are definitely not the same answer. This is not arithmetic. In fact, maybe we could have noticed that because we've talked about the only way to switch back and forth from positive to negative is if you are multiplying by a negative number. So what am I multiplying by? To get from 2 to negative 6, it's times negative 3, times negative 3, times negative 3. So we have a geometric sequence. To find the next term, we multiply by negative 3. Our recursive rule then is start at 2, and to get the next term, go back to your last one and multiply by negative 3. To find the nth term, well, again here we're going to need the 0th. So reverse your pattern. 2 divided by negative 3 is negative 2/3. So start with negative 2/3, then multiply by negative 3 n times. Lastly, our explicit rule needs to be in exponential form. So f of x equals 0th term is negative 2/3 times negative 3 to the x power. Okay, fractions, oh my, mixed numbers. Well, to get from 1 to 1 3/5, I would add 3/5. If I add another 3/5 to that, that gets me past 2 to 2 1/5. So this one is adding 3/5. Once again, feel free to use your calculators, work backwards, trying subtraction and trying division. This is arithmetic. To find the next term, you simply add 3/5. Our recursive rule then is starting at f of 0 as 1. To get the next term, go back to your previous term and add 3/5. To find the nth term, start with 1 and add 3/5 n times. Our explicit rule would say f of x equals, our common difference is 3/5 times x plus the y-intercept is 1. Number 7, more fractions. So if you can't tell right away what's going on, 2 over 625 divided, let me write this down, 2 over 625 divided by 2 over 125. To divide fractions, if your calculator's not handy, you multiply by the reciprocal. So these 2's cancel. 125 over 625 reduces to 1/5. So if I do that one more time, if I say 2 over 125 divided by 2 over 125, I'm sorry, divided by 2 over 25, multiply by the reciprocal, that's 2 over 125, times 25 over 2. The 2's again cancel. 25 over 125 reduces to 1/5. So it turns out my pattern is I am multiplying by 1/5. That makes this a geometric sequence. To find the next term, we multiply by 1/5. The recursive rule would say begin at f of 1 equals 10. To get each new term, go to your last one and multiply by 1/5. To find the nth term, well, we need to know what our 0th is. So go backwards 1 in your pattern. Rather than multiplying by 1/5, we would divide by 1/5. Well, dividing by 1/5 is the same as multiplying by 5. So that's 50. So start with 50, then multiply by 1/5 n times. Our explicit rule then is f of x equals 0th term, 50, times the multiplier, 1/5, to the x power. And last one for the day. We have decimals, which I know you prefer over the fractions, but they are kind of crazy looking decimals. So start at the end, 0.00032 minus negative 0.0016 is 0.00192. All right, then negative 0.0016 minus 0.008 is negative 0.0064. So it's not arithmetic. I guess we could have known that, once again, by the fact that it goes negative to positive to negative to positive. Our only shot is geometric. So let's see what we are actually multiplying by. So starting from the back, 0.00032 divided by negative 0.0016 is negative 0.2. So our multiplier is negative 0.2. So we are geometric. To find the next term, we will multiply by negative 2/10 or 1/5. The recursive rule would say f of 1 equals negative 1, followed by f of x equals f of x minus 1 times negative 0.2. To find the nth term, well, we can't explain that till we get the 0th. So going backwards, I need to do negative 1 divided by negative 0.2, which is negative 5. So start with negative 5, then multiply by -2/10 n times. Our explicit rule will need to be in exponential form. F of x equals 0th term times the multiplier raised to the x power.